Good afternoon, my YouTube viewers. It's Crystal here. I'm just here because I wanted to make another video. In this video, I've taken Module 3 of the course Probability and Combinatorics. And I've taken the coursework and I've converted it to Python. So basically, in the course, everything was done manually. But I just thought it would be a good idea to convert it to Python. So rather than do everything manually at the same time, all the time, you can do it in Python. So the first piece of work that we used was a problem of describe the sample space for tossing a fair coin followed by rolling a single fair dice. So the first thing you need to do is you need to import the library iter tools, and we need to define the possible outcomes for the coin and the die. So the coin is going to be heads and tails, and the die is going to be 1, 2, 3, 4, 5, 6. And now we need to generate the sample space. So sample space equals list, brackets, iter tools dot product, brackets, coin, comma, die, and then we display the sample space. So it's going to be H 1 to 6 and then T 1 to 6. So you're going to have 12 elements in the sample space. So the next question is going to be very similar to the previous question. It's describe the sample space for an element which consists of choosing a boy or a girl, followed by the chosen candidate picking one of 4 items, say soccer, debate, tennis, or crew. So it's going to be very similar to the previous question. It's going to be import iter tools. So we're going to define the possible choices. The gender is going to be boy or girl, and the teams is going to be soccer, debate, tennis, or crew. I'm not sure exactly what crew is, but that's there. And then so we're going to compute the sample space using iter tools dot product. So sample space equals list, brackets, iter tools dot product, gender, comma, teams. And then we print the sample space. So it's going to be boys, SDTC, and girls, SDTC. So you're going to have 8 elements in the sample space. The next question we have is how many elements would you expect to have in an experiment that involved tossing 2 fair dice? What would this sample space look like if it were described by means of ordered pairs? So again, you're going to import iter tools. And so a die is going to be a list with 1 to 6. And then you're going to compute the sample space. So sample space equals list, brackets, iter tools dot product, brackets, die, comma, repeat equals 2. So it's going to be 6 times 6. So it's going to be 36. It's going to be your sample space. So it's going to be 1, 1 to 6, 2, 2 to 6, 2, 1 to 6, 3, 1 to 6, 4, 1 to 6, 5, 1 to 6, and 6, 1 to 6, and with 36 elements. The next one we have is, again, it's going to be on probabilities. It's going to be a candy bowl contains 8 lemon drops and 5 gum drops. Jim selects 1 candy and then selects a second candy. The tree diagram shows the possible outcomes. What are the values of X and Y? So I'll tell you what the values are. X was the first lemon drop, and Y was the second gumball. So how you do that is you define your lemon drops equals 8 because you had 8 lemon drops. Gumballs equals 5 because you had 5 gumballs. Total candies equals lemon drops plus gumballs equals 13. So calculate the probability of a lemon drop taken on the first round. So LD1 equals lemon drops divided by candies. And that's going to be 8 divided by 13. And then calculate the probability of a gumball taken on the second round. So that's going to be the gumballs is going to be 5 because you didn't take a gumball in the first one, divided by 12 because that's 13 minus 1 is 12. And then we print it. So, and that's going to be 5 divided by 12. So 8 divided by 13 is 61.5%. And 5 divided by 12 is 41.7%. So we have another question. This is about dice. A fair coin is tossed 3 times. What is the probability that 3 heads will show up? Define the probability of getting heads in a single toss. So probability of heads equals 1/2 or 0.5. And you calculate the probability of getting 3 heads in 3 tosses. So probability 3 heads equals probability heads to the power of 3, because it's going to be probability heads times probability of heads times probability of heads. And then so you print that off, and you have probability of 12.5%. So we have some other questions about probability. What is the probability of rolling an even number on a 6-sided die? So an even number is 3 divided by 6, or 0.5. Then we have the question, what is the probability of rolling a 2 on a 6-sided die? So a 2 is 1 divided by 6. And what is the probability of not rolling a 2 on a 6-sided die? So there's 2 ways you can do that. It's going to be either 5 divided by 6, or it's going to be 1 minus 2. And they're going to both give you the same answer. So, but it's probably, if you want to work with the knots, it's probably better to say 1 minus 2. But there are 2 ways to do it. It's either 5 divided by 6 or 1 minus the 2. And both of them are going to give you 83.3%. So that concludes this particular video. We've done all the coursework on Module 3, and we've converted it to Python for your ease, so you can see how it's done in Python. So if you like my video, please like and subscribe, and I look forward to making the next video for you, which is going to be doing the coursework in Excel. So thank you again for watching my video, and I'll be communicating with you soon.